Okay, guys. I apologize for what happened last week with my internet connection. So I got that all fixed. And what I'd like to accomplish with you guys tonight is we will continue on with this unit on sensation and perception. And tonight we'll do the eye and the ear. And then I'll give you an open book quiz on the eye and the ear based on what we cover tonight. And that's what I want to do with you guys tonight. So we'll start the eye by looking at the relationship between light and the eye. So let's jump into that. So in order for people to see, there has to be light. Light is a form of electromagnetic radiation that travels as a wave, moving, naturally enough, at the speed of light. So this is an example of what light waves would look like. Light waves can vary in amplitude, that is their height, and in wavelength, which is the distance between peaks. And these are the ways that we influence what we see based on the amplitude of the wavelength and the distance between peaks. The wave of a the wave is of a medium amplitude and wavelength here, but if we click on this, it can show us how changes in the amplitude and changes in the wavelength would be affected. So this would be a high amplitude, short wavelength, medium amplitude, medium wavelength, and low amplitude, long wavelength. If we go here, we have a low amplitude, short wavelength, medium amplitude, medium wavelength, and low amplitude, long wavelength. So the light humans normally see is a mixture of different wavelengths. Light can also vary in its purity, which depends on how varied the mixture of the wavelength is. So the characteristics of light influence our perception of the hue, brightness, and saturation. Before we map out these relationships, I want to make sure that you understand the difference between hue, brightness, and saturation. So when we talk about hue, we're talking about color. So different variations in hue, our perception of that is variations in color. This diagram shows variations in brightness and saturation with hue held constant. The variations in brightness are shown along the vertical axis, and variations in saturation can be seen along the horizontal axis. So the question then is, how do these various characteristics of light relate to our visual perception? If we look at the physical property of light, it will sort of show us how that relates to our perception. So wavelength would be color, right? Different wavelengths would lead to our perception of different colors. Amplitude, very simply, is brightness. The higher the amplitude, the brighter the light. The lower the amplitude, the dimmer the light. And then purity is saturation. The greater the purity, the greater the saturation. For your upcoming exam, we're going to focus primarily on an understanding of wavelength and amplitude. So when light passes through a prism, it's separated into its component wavelengths. What most people can see includes only what we call the visible spectrum, that is, the wavelengths that humans can perceive. But the visible spectrum for humans is only a slim portion of the total range of wavelengths. Other animals have different capabilities. For example, many insects can see shorter wavelengths than humans can see. These wavelengths are in the ultraviolet spectrum. Many fish and reptiles can see longer wavelengths than humans can see. These wavelengths are in the infrared spectrum. All right, let's take a look at a couple of things. So, which of these two waves would have the greater amplitude? And then the answer would obviously be this one. Which of these has a shorter wavelength? Shorter wavelength, again, would be this one. Greatest brightness, would it be here? Yes, it would. Principal determinant of saturation would be purity. Okay, moving on. So now let's talk a little bit about some of the structures that you're going to be responsible for in the eye. So although the sense of sight depends on light waves for people to see, incoming visual input must be converted into neural impulses that are sent to the brain, which we talked about in Unit 1. This information begins in the eyes. So now let's open up a human eye to take a look at the structures. Each eye is a living optical instrument that creates an image of the visual world on the light-sensitive retina at the back of the eye. So the retina is at the back of the eye in yellow here. Light enters the eye through a transparent window at the front called the cornea. Light passes through the cornea and the crystalline lens located behind it, forming an upside-down image of objects on the retina. The image is upside down, but it doesn't matter. As long as the brain knows the rule for relating positions on the retina to the corresponding positions in the world, your perception is right side up, not upside down. Let's talk about a process called accommodation. The lens focuses the light rays falling on the retina. Accommodation occurs when the curvature of the lens adjusts to alter visual focus. So if I click on the distance buttons, we could change how the lens moves so that it changes whether you're seeing something up close or far away. So with a distant object, the lens flattens to give you a better image. And with a near object, the lens gets fatter to give you a better image. So that's how the lens of the eye helps us perceive distance. We'll talk about a problem that some of us have, myself included, nearsighted and farsightedness. So a number of common visual deficiencies are caused by focusing problems or deficit in the lenses. So let's take a look at these. With nearsightedness, close objects can be seen clearly, but distant objects seem blurry. The problem is the focus of light from distant objects falls a little short of the retina. Nearsightedness occurs when the cornea of the lens bends light too much or when the eyeball is too long. Then in farsightedness, the distant objects are seen clearly, but close objects appear blurry. This tends to happen as we get older. The focus of light from close objects falls behind the retina. The focusing problem typically occurs when the eyeball is too short. So the eye can make adjustments to alter the amount of light reaching the retina. The pupil is the opening in the center of the eye that helps regulate the amount of light passing into the rear chamber of the eye. The size of the pupil is determined by the iris, the colored ring of muscle that surrounds the pupil. When the pupil constricts, it lets less light into the eye, but sharpens the image falling on the retina. In bright light, the pupil constricts to take advantage of the sharpened image. In dim light, the pupil dilate and image sharpness is sacrificed to allow more light to fall on the retina so that more remains visible. Okay, and this is where we will end video number 1 for tonight. Video number 2 will be coming up shortly.